Mr. Suhail Akhtar Hashmi is a highly motivated and result-oriented professional with more than 18 years of experience in the field of petroleum refining, fertilizers, and professional skill development. He is a chemical engineer with an MBA executive degree. In addition to that, he has attended many courses on technical and management areas in Pakistan and abroad. Presently, he is working as Chief Engineer in Technical Services Department of Pak Arab Refinery Limited. I now invite Mr. Suhail Akhtar Hashmi to present his paper.
Bismillahirrahmanirrahim. Ladies and gentlemen, my paper is on the impact, what impact fuel is creating on sustainability. So now I will discuss what are different fuel standards, how fuels are being produced, and what technology is being used to help the sustainability in our country. So if I discuss about the objective and scope of my paper, as there are many students I can see also present in this hall, also delegates from industry and the regulatory authorities. So first of all, I would like, before going on to the fuels, I will introduce something on combustion. And then we will look at what is the importance of fuel in transportation. And next, overview of transport fuel standards, which are being implemented in Europe and also in Pakistan. We will also look at the key crude oil refining processes. And next, we will look at what are the fuels which are being produced by the largest operating refinery of Pakistan. And then we will look at the key properties of the fuels which are being produced in Pakistan, especially by the mid-country refinery. So before moving to the fuels, as we all know, that combustion is a chemical reaction between oxygen and fuel. And air, the source of oxygen is air. And there are three mandatory elements for combustion, which are fuel, air, and an ignition source. So as we all know that the atmosphere in which we live, that contains 21% oxygen, 78% nitrogen, and there are some other gases like CO2, hydrocarbon, NOx, SOx, which constitute up to 1%. And as I earlier told you that the three things are needed for a combustion reaction in which air, fuel, and spark is necessary. So in this model, you can see that this is a picture of an internal combustion engine in which all three things are present so that the combustion reaction can start. So what will be an ideal combustion? Ideal combustion will be, as we know that in the fuel we contain carbon and hydrogen. When this carbon and hydrogen reacts with the oxygen, so we will end up with water vapors and CO2 and nitrogen. So this is an ideal condition. If ideal condition is like this, then we will not have too much pollution. And in the previous slide, you can see that nitrogen is passing through the engine as it is not changed. In this slide, we can see a four-stroke engine steps in which the first two steps are intake and compression. The next step is the power stroke, and then the exhaust gases are emitted into the atmosphere. But what actually happens? As you can see in this slide, that in addition to the hydrogen, CO2 and nitrogen, there are some also hydrocarbon, CO and NOx are also being produced. So these are the undesirable components in a combustion reaction which we don't want to appear in the reaction. And on the graph on the left side, you can see the red line is the optimum point where air and fuel mixture is optimized. If we move either on right or on left, you can see what is the impact of different constituents. For example, CO2, hydrocarbon, oxygen, and NOx. So in this slide, you can see that what is the impact of increasing or decreasing the air in the fuel mixture. So when we talk about sustainability, we talk about harmful emissions. So as we all know, that the fuel which presently we are using, that is coming from the petroleum, they're fossil fuels. And out of that fossil fuel, how much harmful emissions are produced, you can see from 1 to 4% CO2 emissions are responsible in the crude oil refining, in the production. 8 to 10% are in the refining sector, 1% when this fuel is transported to the end user, and 85% of the CO2 emissions or greenhouse gas emissions are contributed by the transport sector. So if we look at about the percentage of the emissions, we can see that 23% share is from transport, and out of that 74% is from light and heavy vehicles. And the share of light and heavy vehicle is approximately around 50% each. So when we talk about different emissions and different NOx and SOx production as a result of the combustion, there are two factors to consider. First one is the thermal NOx, and the second one is the fuel NOx. As I told you earlier, that as a result of the combustion, nitrogen should not take part in the chemical reaction. But if some nitrogen is present in the fuel, that will burn and produce NOx. And if there is high temperature in the combustion chamber, then thermal NOx will be formed. So in the thermal NOx area, this is the area where the car manufacturer or engine manufacturers are playing their part, how to reduce this thermal NOx formation. And fuel NOx is where the refineries are playing their part, that how to reduce the nitrogen in the fuel. Now coming to the transportation fuel standards, many countries like US, European Union, Japan, India, different have made their own standards. But in Pakistan, the refining industry and the automotive industry is mostly looking at the European standards. So I have split these in two parts. The first one is Euro standard for passenger cars. That what are the standards, what are the emission limits. And in the second part, obviously these emissions are coming as a result of the engine performance and the fuel which it is being consumed. So I will briefly look at the gasoline and diesel fuel. What are the standards, European standards for gasoline and diesel fuel, as these are mostly used in the transport sector. So in this slide, you can see how the Euro standards have evolved. Starting from Euro 1 to Euro 6, the points to consider are the NOx emission in terms of grams per kilometer, and we have mass of particles also in grams per kilometer, and similarly for diesel fuels. You can see that in 1992, Euro 1 standard regulates that the NOx emission from an internal combustion engine should be around 0.97, and gradually by development in the fuel quality and by development in the vehicles, this is gradually decreased, and now in Euro 6 we should have less than 0.06 grams per kilometer. Similarly, you can see the other figures for diesel. And in the last, you can see that in Euro 5 and Euro 6, we also have a limitation on the number of ultra-fine particles per kilometer. As you see, when this fuel is burned on the roads, people breathe the same in the same atmosphere, and these things may create problem with the lungs and other diseases. So where we are standing and where the world is moving, here you can see that when we talk about the vehicle emission standards, this is February 2015 data. So unfortunately for Pakistan, we have a word written as unknown. So we are still unknown, we are not clear what we have to do. While our neighbor, you can see they are already on the Euro 3 standards in terms of the emissions. So how the fuel properties are evolved over a period of time, if you can see that it is impacted by the growth, it is impacted by the pressure to reduce air pollutants like CO2 and NOx, greenhouse gases. Reduction of sulfur in fuel is the main component of this evaluation. Reduction of sulfur content in off-road fuels and bunkers, and increased content of biofuels. And gradually over the period of time, the different standards evolved, and now in Euro 6, this is 10 ppm. Similarly, we have cetane number and other characteristics of the fuel, which have evolved mainly aiming to reduce the emissions and to produce the sustainability of the transport. Now coming to gasoline, you see the benzene is very important because it is carcinogenic. So it has reduced from 5 to 1%. Sulfur also is important. And then we have research octane number in Pakistan. At the moment, the limit is 87 octane what we are getting. But world has already moved above 91, some 95 and 96. So these factors are directly related to the engine performance and the mileage per kilometer. So when we talk about the different factors, different properties of the fuel, so in this slide you can see how they impact the particulate matter emission, how they impact the NOx emission, how they impact the RVP, how RVP is important. You see, I would like to discuss that in our country, temperatures goes up to 50, and sometimes when we pass through our vehicle, sometimes we smell the petrol smell. So because of the RVP, it heats up and the vapors are emitted from the fuel tank and are wasted. Next, please. So when we look at the fuel sulfur levels, so here we can see that in Pakistan at the moment, we are in Euro 2 less than 500 ppm regulation. But at the moment only the Part-6 refinery is producing Euro 2 fuel. Other refineries are working on it, so it is not fully implemented. Next, please. Where the world is going and where we are. Here you can see that by 2020, most of the nations in the world will attain less than 10 ppm gasoline sulfur limit. And again, in this case, we are around 151 to 500 ppm. We don't have at the moment some clear policies in this regard. Next, please. So when we talk about fuels, when we talk about vehicles, a system approach should be adopted, and here better combustion should be focused on, tailpipe emission controls should be focused on, and obviously the fuel is very important. So what role the Part-6 refinery is creating in this whole scenario, and what initiative we have taken, and how we are going on the journey towards the sustainable transport. Next, please. So for the information of all, MCR is the biggest operating refinery of Pakistan at the moment, with a crude oil processing capacity of 4.5 million tons, which is equivalent to 100,000 barrels per day. So when we talk about sustainability, when we talk about growth, when we talk about initiatives, this is the graph of the Part-6 refinery, starting from a pipeline company and now a multinational company involved in pipeline, in refining and transportation of fuel and in marketing. So this is the journey of the Part-6, how it started in 1981 and where we are at the moment. So as we all know that refining is a manufacturing business. So we have raw material, we have manufacturing plant, and we have products. These are the different petroleum refining processes which are mostly used in the refineries. And when we talk about refineries, when we talk about their complexity, we have different classification, whether it is a topping refinery, hydroskimming refinery, cracking refinery, or full conversion refinery. Parco is in the third category, which is cracking refinery, and all other refineries in Pakistan, they are between hydroskimming and cracking. When we talk about the different fuel markets, so we can see that in America, there is a high gasoline demand. In Europe, distillate demand is more, and in countries like us, we have high furnace oil demand. So when we talk about sustainability, when we talk about different things, so we have petroleum fractions, then we have some contaminants, sulfur, nitrogen, metals, salt, which impact the environment. And then we have some infrequent impurities like acid, hydrogen sulfide, and mercury. Next, please. So if we look at different crudes, they are classified accordingly: sour crude or sweet crude or light crude and heavy crude. So this is a illustration of that. So different refineries, as I told you, some produce greater quantities of heavy fuels, some produce greater quantities of light fuels. Next. And for the information of the audience, roughly this is a percentage what comes out from the crude oil. You can see that LPG is 3%, gasoline is 18%, and 23% is the furnace oil, and approximately 3.5% is wasted in all this refining process. So on the left side, you can see this is what the nature has provided us, and on the right side, you can see what is our demand. So there is a mismatch, and this mismatch is covered by technology, by the refining industry. So this is a MCR mid-country refinery configuration, where you can see the different units which we have. I would like to particularly mention the platformer unit and the diesel max unit, asphalt unit, and diesel hydro desulfurization unit. Next, please. So this is for the students, how the distillation works. Next, please. So diesel mix unit at Parco, this converts the heavy feedstock into the lighter components. And when it was installed in year 2000, it was first of its kind in the world. This is a brief flow diagram of this process unit. Next. And as we all know that in different cars, new cars are coming in, so we know that the octane requirement is 91, 95, or things like that. So this is a plant which is responsible for improving the octane number of the naphtha, and we convert it to gasoline. So Parco in Pakistan is the only refinery which is capable of producing 100 octane fuel. But after blending, it comes up around, as per market demand, up to 87. This is a brief flow diagram of the platforming unit. And how we achieve this 100 round, because our plant has got the continuous catalyst regeneration system, which is unique. No other refinery in Pakistan has got this facility. So by virtue of that, we can continuously make 100 octane round. Next. This is a diagram of that unit. Next, please. So Parco took initiative in 2010, and we have installed a diesel hydro desulfurization unit by an investment of $136 million US, and by virtue of that, we are able to produce 02 diesel, and we are supplying it in Pakistan. Next. Asphalt air blowing unit, all roads are very important, infrastructure is very important for sustainability, and that's why we have installed asphalt air blowing unit in 2012, which is responsible for producing different grades of asphalt. These are the different products which MCR is producing: kerosene, jet fuel, gasoline, high octane, HOBC, diesel, light diesel oil, fuel oil, asphalt, and sulfur. So how the different fuels are transported. This is a share, which fuels are transported by pipeline and which are transported by the road tankers. Next. So these are the specifications which we are producing. You can see that at the moment octane number 87 is being maintained, and we are also providing HOBC in Pakistan. Parco is the only refinery producing HOBC, the octane of 97. And these are the specifications for HSD, Euro 2 HSD specs. Next. So at the moment, Parco is producing Euro 2 gasoline and diesel. Next. And what initiative we are taking, that we are working on a project called isomerization unit, in which we will reduce the sulfur to less than 150 ppm in gasoline. Radon will be increased from 87 to 92, and benzene contents will be reduced from 5 to 1%. Next. And as I already told, the DRDS unit is also helping in producing Euro 3 diesel. At the moment, we can produce Euro 3, and in future, we have option to produce Euro 4 specification diesel. Next, please. Thank you very much.